Hello, this is John with Procure SQL. In this tip, we're going to focus on an extended event that is added with SQL Server 2022. This extended event is the anti-pattern extended event. And so what this extended event will allow you to do is you can actually go through and capture a bunch of code that has been identified to be a bad pattern that you can then review later, find that code, and tweak it so that it can run much faster. Let's go ahead and take a look. All right, let's go ahead and go into the Wild World Importer Sample Database. And then here I'm going to drop an index if it exists. This is one that I've created for this demo script here just to clean things out before we begin. So the first thing I'm going to do is I'm going to create the index here that it is dropped if it existed. And the reason why here is in this demo, we're going to go ahead and focus on the customer purchase order number column, which is an nvarchar. All right. Next thing we're going to do here, we're going to go ahead and create our extended event. And so I want to focus on a couple of things here. As this whole demo is based around understanding how the query anti-pattern event can actually be very helpful for you. So again, this was added in SQL Server 2022. And this event will fire when any one of a series of anti-patterns occurs. So that way you can capture useful information. For example, which application fired off the anti-pattern here? Which server or VM did the anti-pattern get ran on? Some very important identical information here is what was the unique identifier, also known as a query hash, for that query that was executed. Same thing as the identifier for the execution plan. And then, of course, you probably would also want to know the actual text that ran and who ran that text. So these are all actions that we're going to add on top of the event when we capture our event data here. All right, so now that we have that there, we're going to go ahead and turn our event on. And so when we go over to our extended events here inside of Management Studio, and refresh, and we look at our sessions here, now I can watch live data. So anytime in this demo where an anti-pattern that meets the criteria for this extended event, it'll then be captured here and we can see it here. All right, so now that we have that, the first thing you're probably wondering is, well, John, what is an anti-pattern? And so one of the great things about extended events here is you can actually go to the system view for the mapped values to get some insight into what can be caught here. So if we look at these, we're going to see so far, and I'm sure over time probably more things will get added in here, but the ones that we're going to use today in our demo is going to be a convert that's actually going to prevent you from doing a seek. This is also known as an implicit conversion. This is why we created our index on the column that was an nvarchar, because when we try to filter with a predicate of another data type, you're going to see that this is going to create this implicit conversion, which is going to be known as an anti-pattern. Another one here that's common that I see a lot that we'll talk about in our demo is actually a large number of ins or ors in your filter statements here. So we'll have an example here of showing you this and how it gets caught. And then with both these examples, we'll actually have a way on how you could change your code to make your queries run faster here as well. So let's dive in there. So first thing I like to do before I start with my demos here is actually clear out whatever I have there in the plan cache here, and also anything in query store here just to start from a fresh state for the demo here. So we don't have anything else that may throw off our demo or maybe more stuff to see than we need for our demo as well. So I'm going to go ahead and do that. And so here's our very first one here. This is our implicit conversion. So again, what we're going to see here is that this here, our column customer purchase order number, is actually right there. It is a non-varchar 20. And this over here, our actual filter predicate, is actually of a type integer. So here they don't match. As you would see, this is going to be in varchar 20, and we'll say doesn't match with an int. And so this is important to know because when we actually go through, and I'm going to go set up here so we can actually get the amount of statistics for how long the CPU duration was and how much I/O. As you can see, I already got that enabled, but you could do that here, or you could actually go ahead and type the T-SQL to do it as well. And then here you'll see here that we actually have our include execution plan here. So when I run this statement here, we're going to see a few things that I'm expecting because I know that the data types of my predicate 17,913 is an integer which doesn't match the data type of the nvarchar, which is used for our customer purchase order here. And you're going to see this in a couple of different reasons. So for example here, if I look at the predicate, notice the convert implicit int. So this is saying that I got to take all of my columns here, or I'm sorry, all of my rows that have our data here for our customer purchase order number, and we're going to actually convert that to an integer before we do our filter. So because of this, it has to actually go through and scan the whole entire index that we just created. So it's going to go through and read through every single value that we have there for that indexed column there on the purchased order number. So as you add more data over time, the worse this query is going to run because it has to go through and process every single row here in this index. It's also why you end up seeing this exclamation point here. So if we look at the details of this, you're going to see here, in case you didn't notice also, that this is going to tell you that you have your implicit conversion, and it's doing that implicit conversion on the integer for the customer purchase order number column. And here it even tells you that this may affect the cardinality estimate and make your query not perform as well as if you had matching data types from your column and your predicate here. So now that we have that here, we can also go here and look and see here that we ended up reading all of the pages. In this case here, we only have 212, but as we insert more data and this table grows and grows, this is just going to go up here. And same thing here for our duration and CPU time here. So now if we actually go through and we look at our extended event here, we'll see that we captured our first bit of data here. And so for example here, you want to know who ran the query. This was my T-SQL demo account that ran it. This is real helpful because when I have a lot of these, what I like to do is I'll actually aggregate off of the unique identifier, aka the hash, for the query or the plan itself here. And the other thing here is this is going to tell you, remember we saw the different types of anti-patterns? This is our implicit conversion, or the convert that is preventing a seek from happening. So pretty cool stuff that you can get this here, the query, the session ID, all this information here. So that way you can dive through and find out which anti-patterns are hurting you the most and focus on the statements that actually are running the most frequent or causing the most harm for your users there. So really good stuff. So we identified here an anti-pattern, the implicit conversion where the data types don't match. And so how do we fix this? Well, it's actually very easy if you're able to change the data type of your parameter here. So we know here, all right, as we look at this, now we're going to have our n varchar 20, and this is going to equal over here our n varchar here. So these types match. So now when we run this, we're going to see a different execution plan. And so good things here, you'll notice right away, I'm going to switch to green here. Notice that that exclamation point here is gone. And then also the other key thing is we're seeking here instead of scanning, which means we're selectively going through the index to pull the data that we need here. So when we look at our messages here, we can see that our 200 logical reads here went down to 3. And the nice thing here is this will grow as data gets added, but only for the data that you need to pull out of the index. So we're not actually going to go through and scan the whole entire table. We're just going to grab the data that we need out of the index here. And then of course here we can see our duration here is quicker as well. So another thing I like to show here is if you ever have a query where you maybe want to try two different versions to see which one might be better for you, an easy way to go about looking at this would be to just run them both concurrently here in the same window. So as I do this, and we look at our execution plan here, we can see how these two are different. And so, for example, the green here, we know of the whole batch, meaning the two queries, only 1% was used for our index seek here, where 99% of the batch here went for this nasty scan. And the nasty scan occurred here because we had to do that implicit conversion to convert all of the customer purchase order numbers to an integer type so it can match and do the comparison with our filter over here. All right, so if we go back here now, we're going to see we ran this twice. So now we have our two hits here, same session, a time in between them. All right, so we're going to look at another anti-pattern that's included in this extended event here. And so here we're going to see that we have a pretty big in clause here that's going to have a lot of values that we're basically going to get all the purchase order numbers. That's one of these many values that are included in here. And so what we already know from our previous run here is we're taking our n varchar column and we're comparing it to integers. So we already know we should have an implicit conversion check here. But let's see if we also get our or in check to show up here too for the anti-pattern. Let's see if we get one or the other or both here. So when we go ahead and run this, so a couple things to look for. One, again, we have our exclamation point. We already know this is an implicit conversion where the conversion is actually going to force us to scan. And because of that, we have this big thick line which is showing us we're actually scanning across all the data. Another thing to look for in your execution plans after you're seeking or scanning data, usually if you're doing a filter after you're getting the data, that's kind of a warning sign too that maybe there's a way to do your query better to where you can filter as you're getting the data versus filtering after you got the data here. So if we look here, I'm going to show you that we had our two from before, and now with this one query run here, you're going to see here that we have the same query hash, same query plan hash here. The only difference is we got our implicit conversion, and also a large number of ends in our predicate as well. So that's, with one query, we were able to actually trigger multiple anti-patterns there. So that was the one thing I wanted to show you. All right, so if we look at this, and another great thing that I like doing here is taking the results from the statistics here from our time and IO here. I like to just throw this into a website that kind of makes this a lot cleaner to understand. So Richie Rump created this wonderful parsing tool called Statistics Parser. So I'm going to go ahead and paste the output of the set statistics here and tell it to parse. And so here we can see from our anti-pattern of the implicit conversion plus the multiple ends, we got about 11,000 logical reads and about 200 milliseconds of CPU and about 200 milliseconds here of duration as well. Now, let's go look at one way on how you can fix this. And one of these ways is to use TVPs, table variable parameters here. So for example, for the demo here, I'm going to just go ahead and drop and create, but ideally you would have a table type here, for example, for potential parameters that you would use in their data type. So for example, if you had like a value that you would want to filter against that was non-varchar, you would create one like this. So for the demo, I'm going to go ahead and drop this and recreate it, but typically you would have one for your type that you would just use across different filters that you would need for your application here. So we'll go ahead and create that. And now I'm going to go ahead and run this. And so here we can see how long it took to insert into the TVP and also do the same thing for our query where we're filtering using the TVP there. And so if we parse this all in here, we can go get the totals here. And so we can see that we did 4,000 logical reads instead of the 11,000 here. And then also you can see that our CPU went down from 200 milliseconds to 32. And we saved about 100 milliseconds off our duration as well. So again, to sum up this wonderful tip here, if you're using SQL Server 2022, I strongly recommend that you take a look at enabling the query anti-pattern extended event, as this extended event can give you valuable insight into some patterns that are being used in your code that might actually do harm and slow you down or cause you to do a lot more I/O than you actually need to do. Once again, this is John Starrett. If you like this tip, please subscribe, as we're definitely going to add a lot more videos here in 2024 to our social media channels.